Today, we are going on a deep journey into the fascinating history of the universe. How would you like to look up at the sky on a completely dark night with no city lights? Imagine being greeted by the dazzling sight of the Milky Way. You're looking up at this magnificent landscape of stars, planets, and countless celestial bodies. But this feast of light represents only a very small part of the universe. We can only observe a fraction of the Milky Way, but there are trillions of galaxies and billions of stars in each galaxy. Today's dazzling pattern of light is the result of a long evolutionary process. But what was it like in that dark period when there were no stars? And how did the universe become this dazzling light? Let's pursue these questions and discover the story of the universe together. It all started with the Big Bang about 13.79 billion years ago. But the term Big Bang does not actually refer to an explosion in space. The Big Bang describes a moment when the universe began, when all matter and energy gathered in a single point. This initial moment was a time when the universe was incredibly hot and dense. Imagine all the matter and energy of the universe gathered in a single point, and this incredible density and heat caused the universe to begin expanding in all directions at a speed much faster than the speed of light. This expansion process is called cosmic inflation. At that time, the universe was so dense and opaque that not even light could penetrate it. It was like a plasma soup. It was filled with protons, neutrons, and electrons, the basic building blocks of everything. Over time, as the universe expanded and its temperature dropped, protons and neutrons began to combine to form the first hydrogen and helium atoms. This was an important turning point in the structure of the universe. However, at this stage, light was still not being emitted because the density of the universe prevented light from moving freely. This cosmic soup had to cool down even more. The formation of atoms and the interactions of matter and energy laid the foundation for the basic building blocks of the universe. After about 380,000 years, the temperature of the universe dropped enough that hydrogen and helium atoms began to capture free electrons. This process is known as recombination. As recombination took place, the free electrons bound to atomic nuclei, turning them into neutral atoms. This allowed light to move freely through the universe. The universe was now transparent. Light could move freely without obstacles. This was the moment when light became free in the universe and began to propagate freely. This first light is known as the cosmic microwave background radiation. This radiation is a trace from the infancy of the universe and provides us with important information about the early conditions of the universe. The cosmic microwave background radiation is the surviving version of the first free waves of light that emerged as the universe expanded. Modern telescopes and detectors allow us to see traces of this light, and this helps us understand the early moments of the universe. However, after the birth of this first light, the universe remained dark for some time. This period is called the Cosmic Dark Age. The Cosmic Dark Age refers to a period in the universe when stars and galaxies had not yet formed and only hydrogen and helium gases existed. The universe was dark during this period, and more time had to pass before stars and other celestial bodies could form. The end of this dark age brought important changes to the structure of the universe. During the Dark Age, gas clouds began to compress under the influence of gravity, allowing the first stars to be born. These first stars appeared when the cosmic dark age ended and the universe began to fill with light again. These first stars began to produce heavy elements through nuclear fusion processes. At the same time, they heated and ionized the gases around them, allowing the universe to be filled with light again. This process is called reionization. Reionization refers to a period when the dark age of the universe ended and the first stars emitted light into their surroundings. The birth of the first stars caused fundamental changes in the formation of galaxies. The first stars formed the basic building blocks of galaxies by heating and condensing the gas clouds around them. Galaxies are made of giant clouds of gas and dust orbiting around stars. These clouds allow new stars to be born and determine the structural properties of galaxies. The first galaxies formed when clusters of stars merged, leading to the more complex structures of the universe. When we look at the sky today, we can see only points of light. However, these points of light are part of the deep and complex history of the universe. Every corner of the universe bears the traces of billions of years of change and development. This reminds us that every star and galaxy in the sky is the result of a long journey. The expansion of the universe, the birth of stars, and the formation of galaxies are important milestones in cosmic history. This process helps us understand the evolution of the universe and learn how stars, galaxies, and other celestial bodies formed. Ultimately, the universe as we know it today is the result of a long and complex evolutionary process. It began with the Big Bang, when particles came together to form atoms, and then stars and galaxies. Stars are cosmic factories that produce the heavy elements that make up the building blocks of the universe. The light we see in the sky today is a reminder of the universe's billions of years of history. This light gives us clues to the depths of the universe and reminds us how big and complex it is. If you find this journey interesting, don't forget to like the video and subscribe to our channel. Also, for more information about other secrets of the universe and scientific discoveries, feel free to share your ideas with us in the comments section. See you in the next video.